Yo, 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 what's going on, my brothers and my sisters? I am your host, your brother, your professor, Mr. O'Neal Barnaby, founder and director of the Black Math Academy, here with another video showing you what intelligent black society is all about. All right, so today I'm going to be talking about pattern questions. You remember those pattern questions where you had some long decimal and there was a pattern within it and you had to try to find the 335th spot in that pattern. So adding to your repertoire of tricks, I'm going to show you guys a much faster approach to find out that answer as opposed to writing it out 335 times until you get there. All right, so in order to do that, I have to talk about a concept called long division, because that's how you go about finding out that answer. So allow me to reintroduce that concept called long division. Is an OG. We used to move numbers around like an OG. Hey, that was pretty good. Anyway, so long division. So a problem like, let's say, 5 divided by 3. So you would try to divide this value. 3 goes into 5 one time. 1 times 3 is 3. And when you subtract them, 5 minus 3 is 2. So 2 is the remainder. The remainder is what we're going to be using to actually find the spot that we're looking for in the pattern. All right, so this was an old school way to go about finding out the remainder. You just do long division. You get your remainder here, and you were taught to put an R and a 2 next to that answer, so your answer would be 1 remainder 2. And then the next step after that, when you were taught in school, is to see if you can turn it into a fraction. So if you did it again, 5 divided by 3, you get 1. 1 times 3 is 3. 5 minus 3 is 2. This 2 becomes a numerator of a fraction, and what you divided by is a denominator of that fraction. So 1 2/3 would be your actual quotient. And then when they taught you that, they took it a step further by showing you how to get the decimal. So doing this problem again, 5 divided by 3, you get 1. 1 times 3 is 3. 5 minus 3 is 2. At this point here, you would put a 0.0 inside the division symbol and drop that 0 down. 3 goes into 26 times, so the decimal point would go up here. 6 would go there. 6 times 3 is 18. You subtract them, you get a 2 again. So that 2 is going to keep repeating when you keep dividing. So that 6 is going to repeat itself over and over again. So 1.6 repeating would be the actual quotient. And it all makes sense because 2/3, when you turn that into a decimal, is 0.6 repeating itself. So that's how the remainder is used to discover what the quotient or the answer is. But keep in mind, the remainder and the answer are not the same thing. The remainder is just used to help you find out what the actual answer is to a long division problem. All right. So how does this work when it comes to solving a pattern question? Sure. Let's say you had a decimal. This decimal is 0.917350. 917350 ... So it continues that pattern infinitely. And let's say we're trying to find, like the 56th spot in this pattern, let's just say. So what we're going to do is we're going to take the spot we're looking for, 56, and we're going to divide it by the number of numbers in the pattern of the decimal. So we're looking for the 56th spot, so 56. We're going to divide that by the number of numbers in the pattern. So when we take a look, we got 917350, 917350. So there are 12 numbers total, but we want the number of numbers in the pattern, not in the decimal itself. So if you look carefully, 917350, these 6 numbers is what's repeating over and over again. So the number we're dividing by is not 12, but 6, because these are the actual numbers that make up the pattern before it starts to repeat itself. So 56 divided by 6 is what we're doing in terms of long division. And the goal is to find the remainder. The remainder is going to tell us what spot in the pattern is the 56th spot in the decimal. So let me show you. So 6 goes into 56. Let's see, 6 and 8, 6 and 9. So 9 times. 9 times 6 is 54. When you subtract them, you get 2. So our remainder is 2. What that means is, in the pattern that we have, the second spot in the pattern is the 56th spot that we're looking for. So when we look at 917350, let me erase this real quick. 9 is the first number in the pattern, so that would be a 1. Matter of fact, let me switch that up so you can see it more clearly. 9 is the first number in the pattern. 1 is the second number. 7 is the third number. 3 is the fourth number. 5 is the fifth number. 0 is the 6th number, but when you actually do the long division, you won't get a remainder of 6. What you'll get is a remainder of 0. That means that the number, when you divided it, actually went in evenly. So you didn't get a remainder at all. So when you get a remainder of 0, that's actually the last number in the pattern. So 2 is our remainder. So the second number in the pattern is the 56th spot. And when we take a look, that's the value 1. So 1 would be the 56th spot in the pattern. Now that's a lot easier to handle as opposed to writing this thing out 56 times until we get the answer we're looking for. All you have to do is perform long division and you'll be able to get your answer. Keep in mind the goal that you're looking for is the remainder. The remainder tells you what spot in the pattern you're looking for. And also, as an aside, the number that you're dividing by, this 6 in our example, is a clue in terms of what the remainder can actually be. Since you are dividing by 6, your available options for the remainder are all the integers up to 6. So 1, 2, 3, 4, 5. And then when you get to 6, it becomes a 0 because it goes in evenly. And then it'll repeat itself again. 1, 2, 3, 4, 5, and 0. So whatever you're dividing by, the remainder can never be that number, nor can it be bigger than that number. So keep that concept in mind too, because if you get a remainder bigger than what you're dividing by, then you did something wrong. So go back and check what you did. All right. So a problem like this, or rather this approach, is also helpful for a pattern question where you're not dealing with numbers. It's also helpful when you're dealing with like names or any concept that has some sort of pattern in it. For example, let's say these 4 guys, Matthew, Mark, Luke, and John. I know, biblical, but it is what it is. Let's say they're calling into a radio station. Let's say 93.9 WKOIS down in DC. They're calling in, try to win these tickets, and the station says you have to be the 93rd caller to win these tickets. So which one of those 4 guys is going to be the 93rd caller, let's say? So those 4 guys, we've got Matthew, Mark, Luke, and John. All right, so we've got 4 gentlemen in this pattern that are going to be calling in until they get to the 93rd caller. So you look for the 93rd caller by taking that 93rd spot and dividing it by 4 because there are 4 people calling. And then we do this division. Let's see. So 4 goes into 9 twice. 2 times 4 is 8. 9 minus 8 is 1. Drop the 3. 4 goes into 13 3 times. 3 times 4 is 12, and your remainder becomes 1. So that means the first person in that pattern of people who are calling will be the 93rd caller. So in this case, it'll be Matthew. And that's an example of how this approach to finding the answer to a pattern question can help not just with numbers and a decimal, but also any sort of pattern that exists, whether it's numbers or variables or people in this case. There you have it, folks. All right, so there's an example of intelligent Black society. Here at the Black Math Academy, we are clear, we are concise, and we are articulate, which makes us without peer. Don't forget to like, share, comment, and subscribe to all of our social media pages, our Facebook page, our Instagram page, and our YouTube page. And always remember, progress, not perfection. Math is where it's at.